Well, good evening. Welcome to Space Oddities. Thank you so much for joining us. If this is your first time here, thank you so much for joining us. And I hope all you viewers out there in YouTube and Facebook land are all okay and so far enjoying your week, even though it's Monday. And of course, Monday is not a good day for anybody. But anyway, thank you for being here. And on a packed program tonight, we've got a few things to look at. We're going to be having a discussion about the mysterious ocean worlds of the solar system. We're going to be having a discussion about volcanism on Venus. We've got Jonathan with his NEOWatch spot. We have, of course, got the lovely Rachel and the not so lovely Roger, and with their normal spots. And and of course, we've got the news and lots of things going on tonight. So we'd just like to say thank you for being here. If you're watching on Facebook, you are welcome, of course. And without more ado, there's just something I wanted to say to our viewers. We've been having a few discussions recently about where we go with the channel and the content and the type of content we want to bring to you. But we would like to know what type of content you would like. So if you would do me and us a big favor, in the chat, if you have any comments to make about our content, if you think the balance is about right with what we do, if you'd like more of a particular theme or less of a particular theme, or something different that we're just not giving you at all, put it in the chat. All your comments are welcome. And of course, it helps us to get feedback like this because, without you, we can't really mold the direction of the channel, so to speak. So if you've got any comments, please put them in the chat window. And there we are. I'd like to say a big thank you, of course, to our sponsor, Rother Valley Optics, for supporting us. Thanks, guys. And there are a few comments coming up there already, I can see. So thank you for that. We will analyse them later. We're going to have a bit of a swap around tonight because Rachel, poor thing, has not been well. Have you? And a bit tired. And so what we're going to do straight away, we're going to move over to Rachel, if you are ready, Rachel, with this gallery. So let's have a look and see what we have in the viewers gallery this week.
Yeah, but thank you for putting me on first. I'm just hungry and tired and poorly. Always an excuse, but if I sound a little bit nasally, I'm sorry. I won't blow my nose on air. So the gallery today, it's a nice small gallery today, actually. So we're starting off with one by Sonia, which is a crescent moon. And again, as viewers know who've seen Sonia, she uses her Dobsonian on a Google Pixel phone handheld. And she saw this whilst on a Zoom meeting, and somebody mentioned they could see the stars. So she didn't think it was clear, and she ran out, and it was. So she took a quick shot. So
that's lovely.
It pays to be curious and check.
That's a very young moon, isn't it?
It is. New baby moon.
Wonderful.
Looks like it was just short of 2 days old, I think it said in the previous information. So really lovely. And again, for a smartphone, just on a Dobsonian, it's really clear.
Lovely. Well done, Sonia.
Thank you, Sonia. Then we've got one by Jerry, which she's taken one of the Seagull Nebula, which she said is on the border of Monoceros and Canis Major, which is a bit low down for him. But it's still a very interesting part.
Wow.
I don't think I've spent much time looking at this target. So
I don't think I've ever seen the Seagull Nebula.
What?
I don't know. Is that its wings, and is that like a little eye and a happy smile?
Yes, right? Something like that.
Yeah.
Oh wait, no. Is that you can sort of see a beak? I suppose a darker beak coming
sort of
out.
A parrot beak.
Yeah.
Yeah. Is that one you're familiar with, Roger?
Yes, I have imaged it, but not as good as that.
Oh, right.
Yeah. Did it say, is it part of a larger, like, is it a smaller section of a different nebula, or is that it?
That's it.
Wow.
Well, that's only about half of it, but it is quite impressive.
Cool. Yeah. Very good. I like seeing ones that you don't see very often, so thank you, Jerry. Then we've got the Great Globular Cluster in Hercules. This one's by Chris O'Riordan. And he's given us lots and lots of information there, which I obviously won't read at you. This is 2 hours and 45 minutes of integration of 90-second subs. So it's I think it might even be one of our first globs we've had on the gallery.
Yeah, I was going to say we haven't had that many, and that, of course, is the classic one.
But yeah,
that's
really lovely.
Most famous.
It's very nice. I like my
well
globular
resolved that
clusters.
is.
It is. It looks like my classroom floor during Christmas week when we're making cards and the glitter's just gone.
I used to look at it a lot as, obviously a favourite summer target. And I got so good that I could point my telescope directly at it without using the finder scope. I knew exactly where it was in the sky.
Wow. I know, it's really good. Lots of really nice star colour as well. So thank you, Chris.
And Graham says, love Hercules Peak. That's terrific. It is terrific indeed. So well done.
Yeah.
Very good.
Well done, Chris.
And then we put ours. I put this in because I was more shocked of what we could get. So Jonathan took this on maybe 2 days ago, just to try it because we at PASS we took the plunge and we bought some LRGB filters so we can finally get ready for broadband and galaxy targets. And the sky was terrible, but he's really eager, so he was just waiting for clear patches. So he literally took a 15-minute stack. He took 3 5-minute subs of the Needle Galaxy and got this just with the luminance filter.
Wow.
I was really chuffed.
Yeah.
Really
That's
good.
amazing.
For 15 minutes worth of effort, I was like, wow, that's that's pretty cool.
Yeah, absolutely.
Can you not see also another galaxy on the sort
Oh,
of
there's
top
quite a
right?
few.
There's like
There's
2
another
or
one.
3. I
In
know
fact,
they're
there are
like
a few
off
of
to the
them.
left, but I don't actually know
Wow.
what they're called.
Yeah, there were a few of
Fantastic.
them there.
Yeah.
Amazing. Well done. Well done.
And I've just credited Johnny just to keep him happy, you see. So
Oh,
left my name off. And would you like me to share the favourite space image, or?
Please.
So obviously we've got a different edition. So this is a favourite space image picked by some of our viewers, and this one was by Graham Turvey. And I'll read you what he put along with his email. So he said, as I'm old, a good start, I had the pleasure of growing up in the 1960s space race. I don't remember the pic from the time, but when I saw it later, it made a big impression. This is Gemini 6 and 7 in the first rendezvous between the space vehicles. As if one manned spacecraft isn't enough, here we can see another just sitting there. We've got used to pics of the lunar module from the command module and vice versa during Apollo, but more recently with shots of the capsules approaching the space station. But at the time, this image is like something from Thunderbirds. Basically, look, a spaceship and it's in space.
Yeah.
I think the achievement of Project Gemini are too often overlooked in the history of how NASA reached the moon. I'm no expert, just a fan, but he wanted to share his submission of the
Graham,
favourite
thank
pick.
you so much. I'm sorry we didn't have time for it last week.
Yeah. Agreed on that statement, Graham.
But yeah, it does
absolutely.
It does look like something off a TV show, really.
Yeah.
It does, doesn't it? Yeah.
So that would have been 1965, wasn't it?
Yeah, that's right.
So yeah.
Yeah.
And they didn't actually dock, did they? They just rendezvoused.
They rendezvous, that's right.
Yeah. Well, you can see they're not in the correct orientation for docking.
So what's the difference between rendezvous and docking? I'm not quite clear on
Well,
that.
this is a rendezvous, right? So they don't dock. They just pair up in space.
They don't connect.
They don't connect.
Oh,
No.
right. Got it.
Docking is when they actually connect.
Right.
This was an experiment to see whether they could actually put 2 spacecraft together in the same place in space.
Yeah. But later on, they did practice docking with 2 spacecrafts.
Yeah.
Yes. Yeah, I mean, you already need a very high degree of precision in terms of how to position yourself amongst the other spaceship. That's really impressive.
And Vortex says, loved Thunderbirds, as did we all. In fact, I was watching it just a couple of days ago, Thunderbirds, and it was great. And it's been remastered for 720p, and it looks fantastic. So can't beat a bit of Thunderbirds.
I was not raised on Thunderbirds. Did I miss something?
Yes, you had a misspent youth if you weren't raised on Thunderbirds.
You need to binge watch Thunderbirds, Bernard.
Yes.
Okay, I will.
And if you're doing that, might as well watch the Clangers.
That's true.
Yeah.
Having an 8-year-old daughter, I do know about the Clangers.
Okay.
Yeah, so that's absolutely wonderful. And Graham points out, yes, he's absolutely right. The Gemini did not dock with each other; they docked with the
That's right.
Gina
Yeah.
target rockets. And of course,
Yeah.
it was during one of those missions that Neil Armstrong and I can't remember who the other astronaut was.
Oh,
It all went horribly wrong, and
Yeah.
Neil Armstrong showed his mettle even then by saving the spacecraft because it went
yeah,
into
they got into a tumble.
yeah, they got into a spin.
Spin, yeah.
And something went wrong, and they got into a spin. If you watch the movie First Man, which I thoroughly recommend, it's you'll see it there. Great movie. Okay, well, Graham, sorry it took so long to get it to you, but I'd just like to say to all our other viewers, if you have any favourite space images, send them to us with a description of why it's your favourite, and we will show it on the show. And you can send those to Space Oddities live at gmail.com. That's spaceodditieslive@gmail.com. Send us some images because we love seeing them and we love to hear why they're your favourites. So there we are. Okay, sorry, Rachel.
Okay.
And that's it, is it? That's all we have today?
That is it. Yeah, that was our nice small little gallery for this week.
Fantastic. Okay, well, thank you. Do keep your images coming into the gallery. As I said, we do appreciate them. And we love seeing them. And, you know, as we've often said on this program, the skill shown by you amateur astronomers out there is rivaling what you see from professional telescopes. Bernard, why have you got a ukulele there? Right.
Look at the comment and you'll see.
Oh, okay. Right. Okay. Right. I see. Okay. All right then. So, just a reminder. I want to say a big thank you to everybody who bought us coffees last week. Your continuing generosity is really much appreciated, and it helps us to keep things going here at Space Oddities. So, if you would like to buy us another coffee, all you have to do is just to click the QR code, and that will take you to somewhere where you can buy us a coffee if you so wish. And we are very, very grateful for. We've all been absolutely stunned at the generosity of our audience in buying us coffees. We've got enough coffee to keep us awake for the next 5 years, I think. So Jonathan's already showing the effect. Or is that how it normally looks?
No, there used to be I believe, a coffee on sale called Rocket Fuel.
Oh yeah.
Yeah, never actually tried it, but I would imagine that would be the effect of rocket fuel.
Yeah, I can imagine. I must admit that caffeine has absolutely no effect on me whatsoever. I could drink 10 double espressos and sleep like a baby. It just doesn't do anything for me, which is good because I love drinking coffee, but I don't drink it as a stimulant. I like it because I drink it because I like the taste. But anyway, if anybody would like to buy us more to keep us going through the long nights, then please, all you need to do is to scan the QR code, and I'll pop that up again at the towards the end of the program. Moving on. What have we got for you next? We're going to go over to the news now, and as we had Noor as our guest last week, who you may remember was the project scientist for the Parker Solar Probe, we didn't have time to do a lot of things that we were going to last week. So there was no news last week. So I've held it over to this week. So we've got a little bit of a bumper edition for the news. So let's move on and have a look at the news. Got a lovely photograph for everybody. I don't know whether you saw this as the first one.
Oh.
This is the possible site for humans returning to the moon in a couple of years, when we don't know exactly. And this was taken from lunar orbit by the NASA Lunar Reconnaissance Orbiter. And this is over Shackleton Crater near the moon's south pole, which is where humans are going to return to, because there's almost certainly a lot of water at the south pole of the moon, hiding in those craters that are never exposed to the sun. And this is part of the Malapert Massif area. And it is one of I think 14, was I right, Michael? I think it chose 14 potential landing sites.
Yeah, that's right.
And,
yeah.
But this is one of the potential landings. Now look at this landscape. Can you imagine? If you remember back, well, those of us old enough to remember Apollo, when Apollo 11 landed on a fairly featureless plain.
Yeah.
Can you imagine what it's going to look like from the surface of the moon?
I was just thinking that.
Yeah, I mean it's, and the highest peak here, if you want to call it that, is 16,400 feet high, which is
Wow.
an enormous elevation.
Yeah.
And just near it is an 11,480 foot sheer cliff, which is quite amazing. And the principal investigator for the Lunar Reconnaissance Orbiter, Mark Robinson, said one could argue that the sheer grandeur of this region makes it a prime candidate for the Artemis 3 landing.
Nice.
And I don't think anybody could disagree with that. And because this is such a great image, what I decided to do was show you the image on its own. So there we are,
Yeah.
that's the full image. And, if this is the place where humans are going to set foot on the moon again after 50 years, what a fantastic place to land.
I just hope they land in a place where you can still see the Earth,
Yes.
rather than it being blocked by one of the mountains.
Yeah, absolutely.
It's a question-
Well, if
it's
it's
a
at the
question,
South
Michael.
Pole, it
Because
should
the
be
Earth will
fairly
be-
high up in the sky, shouldn't I would have thought.
No, it should. The Earth should be near the horizon.
Oh, yeah, that's true.
Yeah, as depicted in many paintings and drawings over the years.
So the current guess of when Artemis, if all goes well with the Artemis program, the first landings will be in 2025, so only 2 years away. And we've got the Artemis 2 mission before that, which will be a crewed mission, but they will just be going round the moon, much as Apollo 8 did in the days of Apollo, and not actually make a landing. Michael, I think you said that they're choosing the crew soon for Artemis 2?
Next Monday, NASA and the Canadian Space Agency are choosing the astronauts for that crew.
Right.
Four astronauts, including one from Canada.
Right.
So, yeah.
Fantastic.
Because Canada are developing the Canadarm3 for the Gateway. That makes them gives them the opportunity to put an astronaut on one of the first lunar missions.
Sure.
For Artemis.
Just a question, Michael. Are we being over optimistic with 2025, or is that a real possibility?
It's a possibility. Whether it will happen, obviously we don't know yet. But that's what all the NASA press is saying at the moment.
Right.
And hopefully, yes, that will be true. But we'll have to see about that.
Yeah, and the SLS rocket for the Artemis 2 is being stacked together even as we speak.
It is. That's right. Yeah.
So everything is on schedule at the moment, but you never know what's going to happen, as we know space itself. But Nigel, you were going to say something.
Yeah, I just wanted to ask, Shackleton Crater, well, I managed to say it. Is it not also a very interesting place from a geological point of view?
Yes, it is.
Right? It's not only about the water. They also want to try and actually properly explore the moon in a scientific, with a great scientific interest this time.
Yes, because I don't think this type of landscape is fully understood, and they're not quite sure how it got to be as it is. I mean, look at it; it's strange.
Yeah. So the what they're going to be analyzing is going to be very different from the mares that the Apollo has analyzed.
Absolutely, very different composition.
Yeah, fascinating.
I mean, of course, we don't know what they'll find when they do land there, until the robotic probes go there.
No, that's right. That's right. And talking of those, I've got some news of those. So let's move on to the next topic in the news.
Yes.
And these are the new moon suits for the astronauts. The first thing you notice is that they are a lot lighter, a lot less bulky than the Apollo moon suits were 50 years ago. And these have been developed for NASA by Axiom Space. And NASA invited the company to develop these. NASA had a history of many years trying to develop the new moon suits themselves and getting into a real disaster with it. It's been a catalogue of very expensive errors, and they've put billions into it. But Axiom have done it now. Apparently, they haven't revealed how much it costs, but a lot cheaper and a lot quicker than NASA could. This is only a prototype. The eventual suits will, of course, be white to reflect the heat on the moon. But this is basically the suit that people will be returning to the moon in. Isn't that exciting?
I was going to say, how on earth are they going to see an astronaut in the shadows in a dark suit?
Yeah.
I have no idea why the prototype is that
colour. I was going to say it's very light, but it's also very dark.
Yeah, yeah, absolutely. But what you can't see is the big pack on the back, of course.
Yeah,
the big rucksack.
So, notice the big AX logo in the middle.
Yeah, that's right. So this is what people will be going to the moon in. So this is really interesting. Sticking with the subject of the moon, NASA have selected Firefly Aerospace to go to the moon's far side in 2026, and they are going to land payloads on the far side of the moon. Two things they're going to do. They're going to first of all put a lander on the moon and also a satellite into orbit to provide communications with the lunar far side. As you know, obviously the far side of the moon always being turned away from us. So there are communications when something is behind, communication problems when there is something behind the far side of the moon. And Texas-based Firefly Aerospace have put together this lander called, lovely name, Blue Ghost. Nothing to do with Blue Origin, thankfully. And they're also, this lander is also putting the first radio telescope on the moon. And it's an experiment called the Lunar Surface Electromagnetics Experiment Night, or Lucy Night for short. And this has two purposes. One, to understand the moon's radio environment, but more importantly, as far as astronomy goes, it's going to peer into the unobserved cosmic dark ages, that ancient epoch of the universe. And also a thing called the user terminal, which will provide communications support for the radio telescope. So this was a $112 million contract. It's part of NASA's Commercial Lunar Payload Services program. This is where NASA will be flying lots of payloads from different companies to the moon over the next couple of years. I tell you, viewers, it's going to get so busy with things happening to the moon over the next year or so. There's a lot going to the moon in preparation for not just science, but for the Artemis landings. And this is all part of the Artemis program. So well done, Firefly Aerospace.
Maybe we should have a Space Oddities moon channel to focus on everything that's going to be taking place.
Well, I mean, as we were talking about over the weekend, Bernard, I mean, there's so much news coming in now. It's very difficult to include everything, very difficult to keep up with it, and it's going to get a lot busier over the next year or so. Here's an interesting.
Aerials be used as a washing line.
Yeah, you could do that. Yeah, if those new moon suits get a bit wet, then they can
hang them up.
Hang them out. Yeah, they might take a long time to dry, but you know. Anyway, keep taking the tablets, Roger.
Well, that's why they're black, right? Is to dry faster.
Yeah. Okay. Yeah. All right then. Right. Okay. Anyway, I will move on. I'll just ignore that and move on. Here's an interesting one coming out of Mumbai, the Indian Institute of Space Science and Technology. They've been using artificial intelligence, or machine learning techniques, if you like, to look at old data from the Chandra X-ray telescope. And they had about 277,000 targets that were X-ray sources in the sky but couldn't be identified, could not be categorized. Nobody had any idea what they were. And this artificial intelligence has allowed them to categorize these unknown sources of X-rays, which they've, things like black holes, neutron stars, white dwarfs, stars, etc. They've all been categorized with the aid of artificial intelligence. And what this means is that this is a really good example of how artificial intelligence is going to, well, as it is in every field, completely blow the lid off astronomy over the next few years, because these tasks can now be carried out by artificial intelligence, which humans couldn't do. And it's an amazing example of the sort of world that we're getting into, the astronomical revolution, which is just starting, but is going to be mind-blowing over the next decade or so. So there we are. So that's a great result from India, being able to automatically categorize X-ray sources that humans couldn't identify. So that's good news. Then we've got the results of the long-awaited Blue Origin investigation into what happened with the last flight of the New Shepard vehicle, or as is known to us, the Flying Penis, which, as you remember, has been taking rich people into space for very briefly for joyrides. And on its last flight, the capsule release system, which is designed to separate the capsule from the rocket in an emergency, worked absolutely perfectly because there was an emergency. And it's been a bit of a strange story because Blue Origin is so tight-lipped about everything. They haven't been telling us how the investigation's going or what they've found. They tried to blame the Federal Aviation Administration, the FAA in America, saying they don't allow us to release the results of ongoing investigations. And the FAA turned around and said, nonsense, we'd love you to update people on what's going on with the investigation in the interest of transparency. So when Blue Origin realized that excuse wasn't washing any water with anybody, they finally released the report. And they found that what happened, the booster is powered by a single BE3 engine, and the engine nozzle burned through, causing the vehicle to veer slightly off its trajectory, which triggered the capsule release system, which then parachuted down safely. It was uncrewed at the time. It was only carrying scientific experiments. But the reason that it happened was because Blue Origin had been experimenting with a new system to cool the nozzle of the engine, which, as you can imagine, gets incredibly hot. And this new cooling system had the unintentional effect of burning through the nozzle. So they're going to redesign it. But even so, Blue Shepard's not expected to return to flight this year. So moving on, what else have we got in the news? We have got SpaceX reaching near the end of their preparations for their orbital launch attempt. Later, well, we think it will be in April now, which probably means May, but Elon Musk is still saying April. They've been cladding the launch mount that you see in the photograph to stop it being destroyed by the unbelievable force of 33 Raptor engines. And Elon Musk is now saying that as long as the FAA finally gives them a license for the flight, they will be in a position to launch around the third week of April. And you can guarantee that whatever the time of the day or night that launch happens, then we will be here on Space Oddities to cover it for you live, because that is going to be such an amazing historic event, the Starship finally ascending into orbit if all goes well. And we will be covering this live, of course, on Space Oddities. So
I have a question on this, actually.
Yeah.
Why is it called orbital launch attempt? Because obviously a rocket of such power would enable payloads to go far further than the Earth's orbit. So is this like, are they trying this as a test bed or something?
Absolutely, it's the first attempt to get into space, basically. So actually, it's not strictly going to be an orbital flight. It's going to be about 90% of one orbit. The super heavy booster will splash down in the Gulf of Mexico, but the Starship will ascend into orbit, complete about 90% of one orbit, and then splash down off Hawaii. So that's the flight plan.
The reason I'm saying that is, of course, remember when the Falcon Super Heavy took off?
Yes.
A few years ago, it didn't put anything into orbit. It just put something, within the orbit of Mars.
Yeah.
That was quite remarkable. And I thought they were going to do the same stunt, but obviously it's something different.
No, they don't forget that SpaceX are contracted to build the human landing system for the moon.
Right, of course.
And they have to experiment with getting the Starship into orbit, because the lunar Starship, the variant of the Starship that will fly to the moon to land people on the moon, that will need to be refueled in orbit before it leaves for the moon. So they need to get the orbital stuff right before they even think of going any further.
Got it. Makes sense. Yeah.
And estimates vary, but it could be that lunar Starship will need refueling, or it'll require about 8 to 10 Starship flights going up to meet it in orbit to refuel it before it can leave for the moon. And the plan is that it won't contain any astronauts. The Starship will rendezvous, hopefully at the Lunar Gateway, but we don't really know, with Artemis, and the crew will transfer from Artemis to the lunar Starship to descend to the moon's surface. So anyway, exciting times coming. But anyway, late April looks like the date for the orbital launch attempt, and we will cover it live here on Space Oddities. And we'd like to congratulate Relativity Space for finally getting the Terran 1 rocket into orbit. You may remember here on Space Oddities, we made a few attempts at covering the launch live, and both times the launch didn't happen for various reasons, including problems with ground equipment and some idiots piloting their boats into the exclusion zone and bad weather and all that. But they finally got the Terran 1 rocket off the ground. It is powered by methane as the fuel. This is why you get this lovely blue glow from the rocket engines that you can see there. That's methane burning. And absolutely beautiful launch. Everything went fine, but unfortunately the vehicle failed to make it into orbit. The second stage engine experienced a problem and didn't ignite properly. But nothing was lost apart from the rocket because there was no payload this time. This, again, was just a test to see if they could get into orbit. And even though they didn't, Relativity Space are overjoyed because they wanted to collect data about the stresses on the rocket at the max Q point, which is the point in the rocket's ascension when it experiences the most aerodynamic stresses and pressures. And they say they're really happy because they've got a lot of good data from that. They have just demonstrated that 3D printed rockets are viable, are structurally sound, and they actually work. And Relativity Space say they can build a rocket like the Terran 1 in 30 days from scratch, 3D printing 85% of it, including the engines. And this is an enormous step forward. So this is a revolutionary flight from Relativity Space, and well done. They're now carrying on with their plans to build a much bigger rocket, which will be fully reusable, called the Terran R, for medium-sized payloads lifted into orbit. Virgin Orbit, yes, they've ceased operations and they've put their staff on furlough following the disastrous attempt to get a payload into orbit in Britain's first rocket launch from its own soil using the
terrible shame.
It was, and they weren't on a sound financial footing before that, and this disaster was sort of scared a few investors off. So not looking good for Virgin Orbit. It's a blow for Spaceport Cornwall, of course, but it's not all doom and gloom. And as you remember, the Launcher 1 rocket that you see under the wing there of the Cosmic Girl modified 747 failed to get into orbit. There was a fuel filter which became dislodged and which prevented the rocket from reaching its proper thrust and getting into orbit. So I think it was it 2 satellites, Michael, it was carrying? I don't remember. A few satellites were lost.
There was a few satellites, yes.
Yeah. But the good news is that a company called Space Engine Systems have built a revolutionary hypersonic space plane that they have now shipped to Cornwall for testing. And this vehicle, it looks and sounds amazing. So it's not all doom and gloom for Spaceport Cornwall. They have got other people interested in using the spaceport. And they say that, Virgin losing the payload is a bit of a disappointment. That was a bit of a disappointment, the whole mission. But they are carrying on with their plans to expand the spaceport and to get more types of custom going in there. So not all doom and gloom. Sierra Space have also said that they plan at some point in the future to land their revolutionary space plane Dream Chaser at Cornwall Spaceport. But Dream Chaser can land at any airport in the world because it descends like a plane. So whether it comes to Cornwall at some point, we don't know. It'd be good to see it landing at Cornwall, though, obviously. So
I think as well, Andy. I mean, I think I don't know if Michael confirmed this. We've got about 7 spaceports across the UK. I know the Welsh one at Llanbedr, Snowdonia.
Yeah.
Whilst these are pioneers for this, it was always a bit of a case of putting your head on the block in case things went wrong. So hopefully it's also given a heads up for the rest of them that whereas they're like pioneers, Spaceport Cornwall, when things don't go to plan, it can be a great leveler as to finding out that these things are still very much in not an experimental sort of mode, but they're still very much vulnerable to things happening. And it was really, really sad to see the way it went.
Yeah, that's right.
Spaceport Cornwall.
And of course, the first launch for a vertical rocket should be later on this year from Saxaboard in Shetland.
Yeah.
And hopefully that take place later on this year.
Yeah, definitely. I mean, it was so sad that the rocket failed because of $100 fuel filter.
Wow.
After all that work that everybody had done to make that mission a success, it was exceptionally frustrating and disappointing. But anyway, life goes on, and we've got this new space plane from Space Engine Systems, and we've got the possibility of the Dream Chaser using the spaceport. And as Jonathan said, we've got a lot of spaceports now springing up all over the place with lots of very interesting missions that are going to happen over the next couple of years. So Britain, is really at the forefront of a lot of things in space, although a lot of people don't realize that. So moving on. And bad news from Mars. The Chinese rover Zhurong has been stationary on the surface of Mars for a few months now. The American Mars Reconnaissance Orbiter noticed that it has stopped moving. The Chinese, of course, haven't said a lot about it, but it was supposed to, it went into hibernation during the planet's winter. It was meant to autonomously resume activities in December, around the time of Mars's northern spring equinox, when the temperatures were right and it could get enough light to generate electricity, but it didn't wake up. And there's hope that it will with the onset of Martian summer. However, photos from the Mars Reconnaissance Orbiter do show that it's covered with sand, and whether it will be able to regenerate enough electricity to come back to life, we don't know. But if it does manage to charge itself, then it's suspected that operations can resume. But well done to the Chinese anyway, because this photo... tell us about this photo, Bernard.
Yeah, it was one of the pictures I selected.
It was.
It's because it's amazing because it's basically they had a drop camera, which the rover moved forwards. I think it was 5 meters, dropped the camera, moved back, and then it was really made to make the most ideal portrait shot of a robot on Mars. Everything just works here. The colors, the composition. The Chinese really worked hard to make sure that they could show that they were on Mars and they were there. So amazing shot.
Absolutely, and you've got the obviously the lander on the right as well. So lovely, absolutely fantastic.
What they need now is just a daredevil to come over and whisk all the.
If you're gonna say Bruce Willis,
I didn't even mention that.
I thought it was David Hasselhoff with you now. Anyway.
Oh no! Oh my gosh! Let's not start.
Okay. There's a really interesting contract that Rolls-Royce have won from the UK Space Agency to the value of 2.9 million to create micronuclear reactors to power a future moon base. Rolls-Royce have been working for a few years now on developing really tiny nuclear reactors that can be used in a variety of contexts, whether it's military or civil or whatever. And they hope to have a reactor ready to go to the moon by 2029. So good for Rolls-Royce. This is an amazing step forward for, again, UK space. And it demonstrates what I said. There's a lot going on with UK space that people just don't know about. And of course, Rolls-Royce being a British company. Is Rolls-Royce still British? I don't know.
As far as I know, it is.
Yeah. Okay. Great. We never know these days with foreign companies having bought all of Britain's car industry. But anyway, Rolls-Royce are developing these tiny nuclear reactors that are totally safe and as safe as they can make them, obviously. And they will hopefully be powering a moon base of the future. So a lot going on there. And what have we got now? Now this was a biggie, if you like. There has been active volcanism more or less confirmed on the surface of Venus. Now, it was thought for a long time that there was active volcanism on the surface of Venus, and now it's sort of been demonstrated. And there's a gentleman called Roger Herrick, and he got bored in a Zoom meeting, and he was just going through old radar images from NASA's Magellan probe, which you may remember radar mapped Venus in the early 1990s. And he stumbled across two images that were a few months apart, which showed a volcanic crater, if you like, having changed in appearance. And he found some other instances as well. And he said, I didn't really expect to be successful, but after about 200 hours of manually comparing the images of different Magellan orbits, I saw two images of the same region taken 8 months apart, exhibiting telltale geological changes caused by an eruption. And this is what he's talking about. So there's a map of the area, Osamons and Matmons, mountains obviously, on the left. And if you look at the two images on the right, you can see the upper one was the earlier image, and the lower one was taken 8 months later. And the one labeled expanded vent, you can see clearly that has changed in appearance, and there appear to be new lava flows to the north of it. So this is being taken as finally definitive evidence that there are active volcanoes on Mars, and this is on Venus. Sorry, this is a great step forward in understanding Venus, because we know that Venus has sort of basically turned itself inside out several times in its history. So this is a great step forward. Bernard, what do you think about this?
I think it's again shows the richness within the data that we have collected throughout the decades, and there is still so much potential out there. We're going to be discussing about it with the moons of Uranus, and yeah, it's just remarkable that there's still data out there that hasn't. I mean, I thought that they would have done that, as part of the Magellan mission.
That's right.
But obviously they didn't, and it's fascinating.
Was it a NASA Zoom meeting that they got bored in?
It's not specified. It just said a Zoom meeting. Yeah. So, I mean, look at that. I don't think you can argue with that photograph or that radar evidence. There's definitely been a change in that landscape over 8 months. You can see it very clearly. And that expanded vent, as it's labelled, which was circular, now sort of heart-shaped, classic volcanism, basically. So this is amazing news for planetary scientists, who can now move forward with confidence that Venus has got active volcanoes. I seem to remember a study about 2 years ago that claimed to show that scientists had discovered 25 active volcanoes on Venus. But they couldn't really prove any of it. It was just suggested by the data. So now here we've got some actual data showing active volcanoes on Venus, which is quite a thought when you think about it. Okay, moving on. Now this is what we are going to have a discussion about. So there's been the possible discovery that Uranus has 2 ocean moons. These are moons that have subterranean oceans. And the data, funnily enough, comes from Voyager 2. And, of course, it flew past Uranus in 1986. And the data has been reanalyzed. They never stop analyzing the Voyager 2 data because it's such an enormous treasure trove of data about the outer planets that it's always being analyzed. And what they've discovered is some electrically charged plasma around Uranus, which can be explained probably by the presence of moons that have oceans underneath their icy or rocky surfaces. The 2 moons concerned are Miranda and Ariel. And Bernard and I were chatting about this, and we were quite skeptical that Miranda could possibly have an underground ocean, because it's such a weird world that appears to have been broken up and reformed by collision several times. And it's a really bizarre little world. And in fact, Let me just show you. Give me 1 second. So these are the current recognized ocean worlds that all have potentially got underground oceans: Callisto, Europa, Ganymede, Titan, Enceladus, Dione, Triton, and Pluto. We are talking oceans that have, in some cases, several times the amount of water on the whole surface of the Earth. Europa, for example, the little moon of Jupiter, is thought to have an ocean that has more than twice as much water as all of the Earth's oceans combined. So this is, if it's true that Ariel and Miranda can join this retinue of ocean worlds, it's quite an amazing thought. But we are skeptical about Miranda. Here's Miranda. And as you can see, when scientists looked at the Voyager 2 images of this, they thought, what the hell is this? Because just look at it looks like a jigsaw puzzle. The geology is all jumbled up and nothing makes any sense. And the prevailing idea is, as I said, that collisions have broken up Miranda and it's fallen together again under gravity. And this has happened several times to give it this really, really bizarre appearance. And then we have Ariel. This is not a totally good image. This is the best image that Voyager 2 got of Ariel at Uranus. But you can see that the whole moon is just, cut up by these huge cracks. And does this mean that there's an underground ocean driving that? We don't know. So I'd like at this point to say good evening to Lou, which we haven't had a chance to do yet. So good evening, Lou, who's just joined us. And we can't hear you, Lou. So he's just sorting his sound out. So I'd like to bring in Lou and get everybody's thoughts on this. And while we're waiting for Lou, let me just I wanted in particular to look at two of these moons. And one of them is Europa. This is Jupiter's moon, Europa. Lovely image there of Europa. And as you can see, it's got these reddish cracks all over it. It's covered in ice, but the ice is thought to be broken up into sort of ice rafts, if you like, and it drifts about. And it's thought that ocean currents are driving that from underneath. And here's the surface of Europa. As you can see, it's got these weird ridges running everywhere over the surface of the little moon. And see that red color. And I'm not sure if that's the presence of tholins as we go to on Pluto's moon, Sharon. And I'm sure
no, that we don't know.
We don't know what they are.
We have suspicions, but we cannot confirm.
Okay.
Because
And
the data received was just inconclusive.
Yeah. So, but you can see that whole area, roughly going southwest to northeast, has got a huge crack running across it. And I remember that I'd seen an image which demonstrated that these are ice rafts that are moving past each other because they're floating on an ocean. And I actually eventually, with the aid of ChatGPT, believe it or not, I found the image I was looking for, and there it is. Now I've circled the interesting bit here. You can see that there's a ridge running north-south, but you can see clearly that it's on two sides of a crack that has sort of moved past each other, because that ridge no longer aligns. So it's thought that all of this is just floating on a huge underground ocean. Lou, have we got a sound for you yet? No, can't hear you, I'm afraid.
Andy, are we talking that the same principle as sort of the shifts of plate tectonics, but with a sort of an ocean underneath that's sort of driving the sort of shifts on the surface? Is that what we're talking about?
Yeah, so it's a good analogy, basically. If you think of the ice raft as being like the continents, and the ocean currents, because don't forget it's a warm ocean because of the gravitational pulling and pushing of Jupiter's immense gravity. It's heating the crust of Europa, heating the ocean, and these ice rafts are floating on it, and you can see clearly here that two of these sections of
yeah.
ice are, are moving past each other, or have moved past each other. Bernard, anything to say about that image?
Yeah, I mean the movement of these plates are really due to the convection of the heat. That is coming from below, from the ocean, and shifting those plates in many different ways. And sometimes the heat is so great that actually it fragilizes one of the plates or the surface, and then it starts to create some fragile areas where you actually see some of those ices starting to really break up in sort of a circle formation. So it's really, really exciting. Place to be.
And when I remember seeing this image, I think it must have been around not long after Voyager when it was published, and I thought that's definitely moving. That whole thing is just there's movement there without a shadow of a doubt.
I'll correct you on that, Andy. That was a picture not from Voyager, because that is a really high resolution.
Oh, is that from Galileo?
Yeah.
Yes, of course it is. Yes.
Yeah, no worries. No worries.
Yeah, it's a Galileo image. NASA's Galileo probe orbited Jupiter in the 90s, and yeah, it's amazing. It's amazing. Now, also because of this activity, it's strongly suspected that Europa is venting plumes of gas and water vapor into space. These are two images from the Hubble Space Telescope taken in 2014, 2016, and you can clearly see that there's a plume there on both occasions, 2 years apart, which is venting into space. And there's a lovely artist's impression of what that might look like from the surface of Europa, which I really like that image. It gives you an idea of what's going on. So there's a lot of activity going on there relating to all of this heating and convection, as you say, Bernard. And this is thought to be the cross section of Europa, where you've got the deposited material from the plume on the surface. And you've got sunlight, you've got Jupiter's immense radiation cooking the surface, basically, which probably explains a lot of the compounds that those strange reddish color things that we see on the surface. And the ice is probably on average about 10 kilometers or 6 miles thick. And underneath that, you've got those ocean currents we talked about. And also on the bottom of the ocean, probable hydrothermal vents and ice fractures, and on the surface we've got blocks of ice moving about. So it's a really, really interesting world to visit, and of course we are visiting it because with the JUICE orbiter and the Europa Clipper from the US, we will get to know a lot more, but we're going to have to wait till the end of this decade to see it up close again. Anything to say about that image, Bernard?
Yeah, there's definitely a lot of potential that something similar occurs under Enceladus. I don't know if you have slides on Enceladus as well. But
yes, I do.
It's really fascinating, and those those plumes. There's still some not every scientist is convinced about those plumes, but that's just because scientists are a skeptical bunch, and sometimes they need a bit more. But the idea is that we've managed to locate that it is within the region of the Pearl crater, which is one of the hotspots. It had been identified as one of the hotspots by the Galileo sensors.
Yes.
So it's there's definitely something going on there. And one of the potential things that the Clipper is going to do is going to be to identifying one of those plumes and be able to try and target and going to visit those plumes I forgot the name of the probe that went around Saturn. Cassini, sorry, yes, like Cassini did in Enceladus's plume. So yeah. I mean, Clipper's definitely going to try and do that once we've identified the plume again. But they're really going to try and focus on this region called the Pearl crater to identify the plume.
Yes. Just a question. I mean, are we seeing this now in the sort of state of evolution, the way in which we're looking at it now? Are we seeing it sort of in a sort of mid process or progress rather, where it's going to advance to a different sort of state over the years that follow, or is this how it's going to remain because of its orbital positioning?
Yes, Europa has been like this for 4 billion years. It's been in this tidal. It's been heated up by tidal forces, tidal heating for a very, very long time. So this is not an evolutionary state. This is how it is and how it's been for a long time. In contrast to Enceladus, there's still a lot of discussions about, how long has it been, tidally locked and being heated up? We're still talking about, a very long periods of time, hundreds of millions of years, if not billion years.
Yeah.
But whereas Europa, these moons, the 4 Galilean moons of Jupiter, have been, locked into this position for a hell of a long time, which is why, when you consider habitability and potential for life, Europa is the one that that is at the highest in terms of the likelihoods, just because it's had billions of years of it's been heated up, that we know has been heated up, and it's just fascinating. I just can't wait for the Clipper to go there and really provide us with much higher quality data.
Yeah, absolutely. Yeah.
The problem with Galileo,
talking of Enceladus, here is Enceladus, moon of Saturn. Got a high albedo because it's covered in ice. It's an ice coating. Near its south poles, it has these fractures that have been dubbed the tiger stripes, and NASA's Cassini probe discovered that these are vents that are venting water vapor and ice and other gases into space. And here's a Cassini shot of that happening. So you can see very clearly that Enceladus is venting a lot of material. This actually collects to form the E ring around Saturn. It actually makes up one of Saturn's rings, which is quite incredible because there are large quantities of material being vented from these vents. Here's a false color picture of the same thing. You can see very clearly there that from those tiger stripes, there's a lot of stuff being vented into space. Here's another lovely one. You can see it clearly there, although it's not strictly correct to think of those as jets, because they're more like curtains running the whole length of the tiger stripe, if you like. And here's actually what it would look like from the surface. So this would be an incredible sight to see.
Wow.
These curtains of water vapor and ice and gas being sort of squirted out of Europa, for want of Enceladus, for want of a better word. And here's the cross section, similar one to what we saw at Europa. You have the ice shell, which is reckoned to be a lot thinner on Enceladus, maybe half the thickness of Europa. The ocean and the hydrothermal circulation, and then the rocky core at the bottom. Now, interestingly, Cassini actually flew through one of these plumes, sampled its material. Analysis shows that some of the particles had been in contact with volcanic rock on the floor of what is possibly an ocean. And just to give us a slightly more expanded view of that, there are water-rock reactions going on at the bottom of the ocean, and this is where those particles are thought to have come from. And there may also be so-called white smokers. These are like the black smokers on Earth that you get along the mid-Atlantic ridge. And of course, the black smokers are thought to be one of the possible places that life originated on the Earth. And is it the same at Enceladus? Well, as Bernard was saying, the jury is out at the moment on exactly how long Enceladus has been like this. Has it been long enough for any sort of life to evolve? We don't know. But possibly there could be life in the ocean of Enceladus, like there could be around Jupiter. So there we are. So that's a look at some of the ocean worlds. Anything to add to that, anybody?
I just think that when Cassini flew through those plumes, one of the highlights of the mission, I thought.
I would agree with you. Absolutely.
Yeah, and we managed to do it a few times, which is absolutely remarkable, and being able to to detect. Let's not forget that Cassini's instruments were absolutely not designed to do that. That we had no idea we had plumes over Enceladus, and it's only when we arrived and took pictures that people started to realize, we have an amazing opportunity there to fly by Enceladus and go through those plumes. So it's an immense work of engineering, because they had to try and actually not retrofit, but they had to change the way some of the instruments worked and how they were standardized in order to be able to really read the data accurately and understand the data that they were getting from the measurements that were being picked up when they flew through the plumes. So it's an amazing engineering work in itself as well.
Absolutely. Lou, have you got sound yet? Give us a thumbs up if you can hear us at least. Oh, this video is frozen. Well, we hope to get Lou at some point, because I'd love to hear what.
Yeah, absolutely.
So
I wrote a book on this, so I can talk about this for a long time. But I'd love to have the panel and the other panelists talking about it.
So this possible discovery of Miranda and Ariel at Uranus as being ocean worlds as well. I mean, as we were saying, Miranda doesn't seem very likely.
So let me just give me a few thoughts on that. So Miranda was in resonance when it was in the early stages of the Uranus system, and so there is some thoughts that it would have melted. The ocean inside would have been liquid but in the early stages, but because it's so small, it would have frozen up. Just because it hasn't got the same situation as Enceladus. It's the same size as Enceladus, but Enceladus keeps on being pumped up with heat, whereas Miranda doesn't. On the other side, Ariel is an amazing moon, and I read here. I'm going to read again. Ariel, after Enceladus, Ariel displays the most active surface of any icy moon in the Saturnian and Uranian system, and it's one of the most interesting moons of Uranus, so much so that for quite some time planetary scientists were even trying to detect if there was something similar as the E-ring, which is around Saturn. You have this plume, this big ring that is basically the seawater of Enceladus being vented out and forming this ring around Saturn, and we suspect that something similar must be occurring around Uranus. So it's just a matter of we just need to go back there with a proper probe in order to really start to collect data. Obviously, the main problem with all of this is that we know very little of any of these moons. We only have mapped out 30%, 35% of Ariel's surface, 35% of Miranda, Titania, the biggest moon out there. We've only mapped 40% of its surface. We know very little of this system, which is why we need to go back. But it's fascinating, and for me, it's one of the most amazing at least information in terms of ocean worlds for since the last 10 to 15 years. This is great for me to be able to go back, and it's not a line of evidence, but it's starting to get really it's starting to push us there and to make us look back into the data, because ultimately there are 5 confirmed ocean worlds, as you stated, Andy. Ganymede, Callisto, Europa, Titan, and Enceladus, and then you have the others, that are really, we pretty much say, they're almost there. We just need that line of evidence, such as Dione and Triton.
isn't Mimas meant to be one as well? That's suspected.
Oh,
I did read that a while ago. I was a bit skeptical.
Yeah, there's a lot of back and forth on Mimas. There is a lot of, every few years basically is really funny. It's every few years you have a new model that comes out, a new statistical research that comes out, and they're like, yeah, we think it's an ocean world, and then 2 years later, no, we think it's not. And it's related to Enceladus. If you really look into detail, it's really fascinating because if it works on I need to look back into this, but basically if you apply a theoretical model on Mimas, it has to work on Enceladus as well. And
Yes.
And sometimes they show, oh yeah, Mimas has an ocean world, but hold on, that model doesn't work with what we're seeing on Enceladus. And so yeah, I wouldn't go for Mimas just because it's really small as well. Just like Miranda, it's these ocean worlds are really these moons are really interesting, but at some point you get so small, the heat that if you don't have this tidal heating that sort of pulses heat through you, you're going to lose that heat very quickly.
Absolutely.
The heat that you've picked up billions of years earlier.
Yeah, and we have to remember we're talking billions of years.
Yeah, absolutely. And again, Ariel was in resonance with Oberon and Titania, which are two of the largest moons of Uranus. So it was in resonance in its early stages, and it got really pumped up with a lot of heat. But the cool thing is that Ariel is still in resonance. It has a slight eccentricity into its orbit, and therefore it still has heat pumping into it. Not as much as Europa as Enceladus, but there's still something there.
Still some heat, yeah.
Whereas Miranda, there's nothing there anymore.
Okay, can I just stop for a moment? Do we have Lou with us? Lou, say something.
Yeah, it would be great to hear you, Lou. I'd love to have you.
Yeah, we can't hear you, Lou.
Well, we can push this for next week.
Well,
again.
Listen, what we'll do, Lou, we'll carry on this conversation next week because we would like your input on this, and we'd love to hear what you think about all this. So we will definitely carry on this conversation next week. So I suggest what we do now is move on so we don't exhaust this. So we've got something to talk about with Lou next week. But of course, you're very welcome, Lou. I'm really sorry that your sound isn't working. Technology, just when you need it to work, it fails. Okay, I just want to pick up a couple of things that our viewers have said, actually. Thank you all for your comments. And Chris says, you can take this one, Bernard, if you like. The Hubble images also show the cracks on Europa haven't moved in 2 years. Is this a slow process?
No, I'm not familiar that the Hubble telescope has the resolution enough to show cracks. You need to do a flyby mission to be able to have enough resolution within the imagery to actually show cracks in itself. However, is it a slow process? That's a very interesting question. We actually don't know, but there is definitely ideas that it is moving and it is happening, it is occurring.
Yeah.
And I'd love to have Lou here, so maybe he could confirm or provide more details on this. But I mean, obviously, it is going to be a slow process, just because we're not talking about an enormous amount of energy. We're still there's still a lot of heat in there, but these big ice shells are they're big, they're vast, they're heavy, so it is not going to be very rapid in itself.
Yeah, absolutely. And Simon wants to know about the Rolls-Royce thing. How do you safely transport a nuclear reactor into space? Which is a good question. But they did it with the the RTGs for the Voyager and Cassini and other probes. So I'm sure that they can make them equally as safe as that for transporting into space. I mean, for the RTGs that powered these probes to the outer solar system where there's not enough sunlight for solar panels, they drop them out of aircraft at 50,000 feet to see whether they'd survive the impact, and things like this.
I remember there were even people that were on the picket line for the
Cassini.
Was it not for the Voyagers as well? The Voyagers were the first.
Don't remember that for the Voyagers. My memory's not gone back. Well, it goes back that far, but I can't remember. But definitely Cassini. There were huge protests.
Yeah. Like people like Greenpeace and Friends of the Earth, maybe, and
everyone was there. Yeah, and Jonathan Porritt was there. Whatever happened to him? Jonathan Porritt disappeared. Thank God. So yes, so I'm sure they'll work something out to get them safely into space. So don't worry. Okay, let's move on. They're celebrating a birthday. We're celebrating the 10th anniversary of the ALMA radio telescope. So happy birthday, ALMA! And I just thought I'd tell you a little bit about ALMA and show you some of the things that it's been doing. So ALMA is a radio telescope in Chile, and it sits high up on the plains of the Atacama Desert in Chile. It comprises, it's 16,400 feet above sea level. In a weird coincidence, that was the altitude of the mountain that we were talking about on the moon in the photo. Just thought I'd say that. Anyway, it consists of 66 movable, steerable radio telescope dishes, and it has the mission to observe the cold, dusty universe because it works at millimeter and submillimeter radio wavelengths, which is where all the cold stuff is, basically. This is the cold, dusty universe generates radio waves at that frequency. It's an amazing project. The project itself is a partnership between the United States, Europe, and Japan, with Canada, Korea, and Chile itself taking a smaller role, making valuable contributions. And this telescope is so unbelievably sensitive. And one of the great advantages it has is that these dishes can actually be moved about and placed in different configurations depending on the type of observing they're doing. And there it is on the plains of Chile. And as you can see, there's a transporter there with one of the dishes on its back, moving it to another base. And they've got a large number of different configurations for looking at different types of objects. And here is one of those transporters. Each one of those dishes weighs 100 tons. So these obviously had to be purpose built to carry dishes of that weight around. And it's not far from, they think it's an extinct volcano. I love this photograph. It just shows the barren landscape that the telescope operates in. And there is so much, a lack of air there at 16,400 feet that everybody working up there has to wear oxygen all the time. And you can see this engineer here, this gentleman, he's got oxygen fed to him. So it's not a nice environment to work in, but they've managed to do amazing things up there on the plains of the Atacama Desert. And just to give you an idea of some of the images that the ALMA telescope has produced, well, I think this is my favorite. This is a protoplanetary disk around the star HL Tauri. And this is a disk of material around a young star. The black rings are where young planets have swept out the material from the disk. So you can clearly see here where there are planets. And again, this is cold dust around this star that ALMA is particularly sensitive to. There you are. Now, people often say, there are people in this world who think that the Earth is special and it must have formed in a different way or been made in a different way. And we are looking at... Hello? Who was that? Somebody trying to get through and can't hear them. Okay. Yes, we've got you now, Lou.
Hallelujah.
Hurrah. Hurrah. How are you? Anyway, we'll come back to you in a moment, if we may. Another image from ALMA. This shows another protoplanetary disk, and this has a larger black ring. This is a planet about the size of Saturn forming around this star in Ophiuchus, AS209. So we're looking at a planet in formation there. And here's another one around the star HD 163296. And here, astronomers believe there are about 4 planets the size of Saturn forming around that star, 4 gas giants forming around that star, which is quite incredible. But these are not the only types of images that the ALMA telescope can acquire. It's a really flexible telescope. Now, this is supernova 1987A, which some of you may remember. I remember when it happened. And it looks particularly bizarre for a supernova. Just let me explain what you're seeing here. When or before the star went supernova, somebody got their volume turned off. I'm getting an echo here. when or before the star went supernova, it ejected vast quantities of material into the interstellar medium. And when the supernova explosion happened, eventually the explosion from the debris caught up with the material the star previously ejected, heating it up dramatically. And this is the result. It's like a string of pearls, if you like, around the star, showing where that material is slammed into the previously released material. So it was long thought that a neutron star had formed immediately after the supernova, but no characteristic radio signals from a pulsar have ever been received. Perhaps the jets from the pulsar are pointing in the wrong direction or whatever. So we've never seen a pulsar since 1987, but ALMA has detected this hotter area in the middle of the supernova remnant, and it's thought that there's a pulsar hiding within that blob that you see. So the astronomers are fairly sure now that there is a pulsar, and that's where it is. So that's an amazing image as well. This is interesting. This is a ring of pure salt. Yes, your common table salt, sodium chloride, around a star in the Orion Molecular Cloud 1, which is in the background there as imaged by the Gemini telescope. And this is a ring of pure salt around a star. Salt has been seen before around stars, but not in this detail and not as a complete ring. So it's amazing to think that there's a huge quantity of salt around this young star. And again, no other telescope except ALMA is able to see this. And of course, ALMA has looked at the planet. Here it shows an organic molecule called methylnitrene, or HC3N, in the upper atmosphere of Titan. And this is another thing that ALMA is particularly sensitive to. But of course, I think the most famous image that ALMA made a contribution to was the famous Event Horizon Telescope image of the black hole in M87, this iconic image. And only by adding ALMA into the Event Horizon Telescope array could this image be achieved, because ALMA gave the whole array the definition that it needed to acquire this image. So ALMA made significant contributions to that image, and also, of course, to the image of Sagittarius A star, the black hole at the center of our own galaxy. So there you have it. So that's ALMA. Happy 10th birthday, ALMA. We hope you'll go on to produce more amazing images from many, many years to come. So there we are. So Lou, anyway, how are you?
I'm doing well, and thanks to everyone for your patience. I had to reboot and change web browsers before I could get things working. So,
oh, goodness me.
Where there's a will, there's a way, I guess, right?
Absolutely, absolutely. So I'm sure you saw what we were talking about. So what do you think about this latest news of, new ocean moons, as it were, around Uranus?
Yes, so I had plenty of time to think about it. We do call it an icy outer solar system. We call it the icy moons of the outer solar system. And the average density of these moons is generally less than 2 grams per cubic centimeter. Earth is 5.5. Earth is very rocky. So there's a lot of water out there. And so what you need to have liquid water is water and a heat source. So I would imagine that any moon that is even a slight eccentricity, Titan, for example, has a 3% orbital eccentricity, and there's thoughts now that there may be liquid water or some kind of liquid water hydrocarbon ocean under the frozen surface of Titan. So when you have densities that low, there's a lot of water out there. And so it doesn't come as quite a surprise to me. It also appears to be the case that if you can make a sufficient case for a subsurface ocean on your body, that your odds of being selected as a mission to go there go way up. So I think there's plenty of motivation for doing this. But it is not that big a surprise to me.
As regards the water itself, there was another recent discovery of a young star that has a huge cocoon, if you like, of water surrounding it that's never quite been seen before around a young star. And this may help us to answer the question as to where all the water in the solar system came from, particularly, obviously, the water on the Earth, whose origin we've never been sure about. So could this be the case that the water didn't come from anywhere because it was already there as soon as the star was born? There was a huge amount of water around it. Got any thoughts about that, Lou?
Well, water appears to be ubiquitous throughout the universe. Hydrogen is the most abundant element. Oxygen is what?
Yeah.
Fourth? Fifth?
Yeah. And Chris says, why does water appear to be concentrated in these few moons rather than being dispersed more evenly? Anybody want to take that one?
No. So basically, water. Wow, I'm hearing an echo as well. So basically, as Lou mentioned, there's pretty much water everywhere. As soon as you hit the frost line, basically from Jupiter onwards, and therefore, the concentration of water on the moons, even on Jupiter's moons, is phenomenal, like 50%, 60%, and further on as you go. So it's being dispersed evenly, but obviously it's being concentrated in these moons, just like rocks and iron are being concentrated by gravity, or around these planetary systems. Lou, you wanna add to that?
I absolutely agree with what you.
So yeah. So I mean, we basically need to go back to the outer solar system, don't we? I think that's the bottom line. But there are no immediate plans to do so, and it's a shame that, in my view, NASA seem to be concentrating on going back to Venus rather than sending a new probe to the outer solar system. But let's hope that that changes, because I know there's a lot of pressure for NASA to go back to the outer solar system.
Yeah.
With new technology, just think what we could learn. And
I believe the
what we can do with fair technology. So we will see what happens. But I doubt whether I'll see it in my lifetime, that's for sure. So
I think Lou wants to say something.
Can you hear me?
Yes.
Yeah, I believe that the latest planetary decadal survey has a Uranus orbiter as a high priority. So we'll see how that moves forward.
Yeah, absolutely.
It is actually the highest priority within the planetary decade. And just to confirm, Lou, oxygen is the third most abundant element.
There you have it.
Yeah.
There you have it.
Yeah, absolutely.
We should all be drowning.
Yeah. Okay. Well, thank you for that. I mean, I'm sure this is a subject that we will return to, and I'm sure there'll be more information about Miranda and Ariel coming up in the coming weeks or months. Now, what we're going to do now, we're going to move over to Michael. And Michael, I think you've got some interesting news for us.
Yes, I have. Do you want to start the?
Yep.
Yep. Okay. Thanks for all that discussion on the ocean moons. I'd like to bring you all back to Earth now. I'm getting an echo as well, by the way. Okay.
Yeah, I think I'm not quite sure where the echo is coming from.
No. Okay.
So, Lou, could you do us a favour and just put yourself on mute, because it might be coming from you. And let's just find out. Oh, I can put you on mute, actually. There we are. You're on mute now. Okay, Michael, carry on, please.
Yeah. All right. That sounds a bit better, I think. Right. Yeah. Yes, I'd like to introduce you all to Dawn Aerospace, which is a New Zealand-based satellite launch company, which I came across some months ago, actually, when they produced a video about this very nice looking aircraft, which is actually their new space plane. When I saw this, you can see the size from this picture depicted with the company's CEO, whose name is Stephen Powell. But this is the actual spacecraft that will be going into a suborbital flight above the Kármán line. And the news now is that the New Zealand FAA, the New Zealand version of the FAA, has granted them a license to do that.
Fantastic.
And it should actually take place next month. The mission of the Mark II, which is that spacecraft that you've just seen there, Mark II Aurora, is to fly into space just above the Kármán line twice a day, and in doing so, to demonstrate that the rocket-powered systems can be as reusable as commercial aircraft. Now, of course, being that small, there's no chance for a crew or humans on board. This is all remotely controlled space plane, which I think is a brilliant idea. And for small satellites. So let's look out for that next month.
And we should point out that we see in the photo is the full-size thing. That's not a scale.
It's full-size thing. Just a few.
That's the full-size thing. Yeah.
Yeah, just a few stats here. 4.8 meters long. Takeoff weight 350 kilograms. Empty weight 118 kilograms. Propellant is HTP stroke kerosene. Can you say what HTP is, Andy? Is that standard rocket fuel?
Yeah, that's right.
Okay. Maximum speed Mach 3 plus, and maximum altitude 110 kilometers. The nominal height for the Kármán line is 100 kilometers, so it just actually does theoretically get into space, but it is again only a suborbital flight for this particular model of the Dawn spacecraft. But it's just I think an amazing and different concept than other companies have come up with before, and it's good to see different countries trying different things now, and it's good to see that the New Zealand FAA have granted their license for them. It's pity the UK equivalent took so long per hour. Anyway, just a few more slides on the Dawn. And this is so there'll be some quite a number of flights with the Dawn Mark II, but later on they'll be producing Dawn Mark III, which is larger, but still only 22 meters in length. And it will carry a rocket propulsion stage to deliver payloads of up to 250 kilograms into low Earth orbit. So they are going into the orbital market as well a bit later on. Once they've done, a number of flights with the Mark II, and they'll develop the Mark III. So
So Michael, is it me or these all look very boring? I mean, it's
what do you mean very boring? This is Thunderbirds, mate.
Yeah,
Thunderbirds.
And the fact is that they because it's launches and lands like an aircraft, they can use any major airport in the world to launch their payloads. So
fascinating.
And thank you, Keith Maslin, for telling us about HTP, highly concentrated solution of hydrogen peroxide. There we are.
Yeah. Okay.
So thank you very much.
So there's the difference. Dawn Mark II is just 4.8 meters long. I like their little diagram. This is actually off the Dawn website, and they've got a stickman as a human.
I was going to say they need somebody a little better at drawing. Humans,
this is Dawn Mark II, which is the 4.8 meters long. Then Dawn Mark III, which is 22 meters long. So that's okay. So that's the details on that. And this is just a diagram of the stages of flight. The Mark II just going, as I say, just above the Kármán line. but the Mark III will also go above the Kármán line and then deploy an orbital stage to take satellites into orbit. So,
Brilliant.
that's
I'm from New
really
Zealand as well.
interesting.
It's brilliant news.
Yeah,
Really
thumbs up for New Zealand, as you say.
So that's Rocket Lab and Dawn Aerospace coming out to New Zealand.
Yeah. Yeah, I'd like to, if this works, I'd like to show a short video of this particular Mark II spacecraft. It does really look like a cut down version of what it should be, but
unfortunately the video won't work unless you share your screen. So,
okay. Oh, right. Okay. Fair enough. Yeah. All right.
Which you're welcome to do, of course. But if you want to
you can just look for Dawn Aerospace New Zealand on the web, and you'll find the video of the space plane.
Fantastic.
So that's what I wanted to show. But what I will do, that's the end of my presentation about Dawn Aerospace.
Right.
But I'd just like to remind people, if I can, that on Thursday, the 6th of April, we have a Ghost Space Watch meeting in a talk by Ben Evans entitled the Tales of the Challenger, all about the Space Shuttle Challenger and its history and what it could have achieved if it would have gone on to greater things, as it were.
Right.
So that's on the 6th of April. So thanks for that, Andy.
Thank you very much, Michael. That's fantastic. And the commercial space program, if you want to call it that, is just it's accelerating, and there are so many companies now springing up. We can't keep up with them all, can we?
No.
It's so much going on in space. The next decade is going to be truly amazing.
It's like waiting for buses.
Yeah, absolutely. So there we are. And let's try putting Lou's sound back on for him and see whether we still got the echo. Yes, we have. Bye, Lou.
Here.
Oh, no.
Yeah. I think we still got an echo on the sound coming from your equipment somewhere. So I'm going to have to mute you, I'm afraid. So sorry.
we can carry on, discussions about ocean.
Yeah, we'll carry on next week, Lou.
Next week,
carry on the discussion
absolutely.
next week. We'll carry it on to next week. Alternatively, of course, Lou, you can post in the chat, or you can use semaphore flags if you would like to. So there's no need to swear, Lou. Okay. All right. Thank you. And thank you for taking part in the discussion. Well, this brings us to our weekly NEOWatch with Jonathan, Near Earth Object. Jonathan?
Yes.
Jonathan joined Space Oddities as a panelist recently, and amazingly, he's come back for more. So
yes, I know. What am I doing?
Yeah, exactly. What are you doing? So what have you got for us this week? Can I just ask, as we were talking about earlier, there does seem to have been a large number of stories in the popular press recently about hazardous asteroids and we're all going to die and this sort of thing. Is there anything to this, or is there any?
No,
is there
not
any?
Really.
No, I didn't think so.
No, nothing to worry about. That over the next 48 hours, we've got 4 or 5 reasonably sized asteroids heading this way. It's almost like somebody's taken a scattergun to us, but none of them are going to hit. The margin for being struck is substantial. So again, it's just running with that theme that we are going to get smashed one day, and that one of these will inevitably, it is going to happen. But I discount the ones that that are picked up in the popular press. I mean, one which was significantly exaggerated was 2023 DZ that sailed by on March 25th, Saturday, March 25th. This one measured around about 70 meters in diameter, and it passed the Earth at just under half the distance to the Moon. And we have to go back to 2019 to find any sort of similarity with the distance from Earth and size relating to 2023 DZ. However, that asteroid was called 2019 OK, discovered just a day before it passed the Earth on July 24th. Now, this particular one of a similar size, 2023 DZ, was sighted back in February of this year, the 23rd. So maybe they're more eyes on the skies, even in the span of 4 years, are beginning to pick these things up earlier. The 2019 picked up just a day before it actually passed. This one picked up a good month or so before it passed. This particular one, it's got a 6-minute rotational spin, elongated in shape, similar orbit around the sun as well to 2019, okay, around about 3 years. Although passing us, it did tighten the orbit somewhat. Its perihelion is April the 4th, and the next flyby is April 23rd, 2026. And 2023 DZ is part of the Apollo family of asteroids, those that are Earth crossing, likely to intersect our orbital path. And as of March 1st of this year, there were 17,540 of them. So
Wow.
very much bigged up 2023 DZ. But last week as well, we were talking about our perceptions of what we're doing about it, and what as a global effort to address these sort of matters. And we've got plenty of conferences on the way. And the next major conference is on April the 8th. It's the International Academy of Astronautics Planetary Defense Conference. I don't think anybody who actually got a ticket to go in would like to see that on the door. It's between the 3rd and the 7th of April in Vienna, Austria. And some of the topics they're going to cover are impact, effects, and consequences, disaster management and impact response, public education and communication, and also this one, which is rather intriguing. I found it's almost like a need-to-know basis, where it's called the decision to act on a political, legal, social, and economic aspect, because obviously if one sort of falls within a sort of remit of being particularly close, it's whether or not to call it as being something that may well lead to a substantial disaster. So a major conference on the way, and that's one of a sequence of about 4 that are on the way in the next 2 to 3 months. And also courtesy of the European Space Agency, as it stands at the moment, just a day or so ago, the current total of near-Earth asteroids that we are tracking at the moment comes to 31,533, and 1,463 of those are on the risk list. The current near-Earth comet tally is still around the 120 mark. And interestingly enough, the current number of near-Earth objects discovered since the start of the year stands at 336. And as of February, we saw 144 added to that list to give us a total of 336. But Andy, I think, like you say, the media full of these. It is basically scaremongering. They are. It's just the fact that we've got more eyes in the skies. It's something to latch on to, but it's almost like a cry wolf scenario. You keep on banging on about it, and it will sort of drop off the radar. And that's what we need to be conscious and very mindful of. If we go and do that, then the real ones that we want to keep an eye on. Like I've said last week and the previous weeks, those are probably ones that will sneak up on us, like 2019. Okay, with just a day to go, nothing we can do about it, and those are the ones that would cause the most alarm. But it's nice to see the conference there addressing the sort of decision to act with regards to where these things are going to happen, how they're going to relay such information to the public. And yet again, though, in true Bruce Willis mode, we are still unequipped really to deal with anything of a major scale at the moment. But from the NEOWatch desk, that's it.
Thank you, Jonathan.
I
think the Daily Mail newspaper in the UK, as I think I told you, in 3 months it carried 68 asteroid scare stories. And it seems like what they do when it's a slow news day. Oh, what should we fill the column inches with? Oh, an asteroid story. That's always good fun. But these have real consequences, because if you remember 2012, when the world was going to end because of that Mayan prophecy that some people made an awful lot of money out of. I know in America there were some school children who were getting literally suicidal because they thought the Earth was going to end. And these stories do have real world consequences. It may be great to sell newspapers, but for people who are children, especially of a nervous disposition, it's just not a good thing to keep plugging disaster.
No.
But disaster sells. So
well, I think that Chris has mentioned something nicely in the the comments box there. Is that one of the crucial factors is this late spotting or what we've seen when you talk it was just a day before it actually, or in some cases it's actually gone by us before they actually pick it up. And I think that's probably the key part behind the scaremongering is some of the lateness that we are picking these things up. But that percentage has dropped considerably over the last decade or so because of the way in which we observe the skies at the moment. So to be caught cold like that would give us no chance to do anything whatsoever. But yeah, it's the fact that still the ones are catching us, especially if they come directly out of the sunward direction. Well, we just can't pick them up as quickly as we could normally. But when you consider that we are tracking over 31,000 of these, that brings the stats down significantly. But yes, Chris, probably quite right there. It's the potential impact and the fact that of the ones that we do pick up very late indeed.
Yeah,
I'd like to add about the scaremongering. I was listening to the radio this weekend, and it was like full on. We have a city killer asteroid coming near Earth.
Skyscraper,
and they just throw these names out that
it is irresponsible for those people of a nervous disposition. It is.
Like you say, Andy, if they went with large rock will pass us at a safe distance as the headline,
it wouldn't sell.
Exactly. There goes another one at a safe distance.
Well, we've all, of course, been having great fun laughing at their units of measurement for measuring these objects as well. 69 American alligators was one. The diameter of a Ferris wheel was the other.
Something that's the size of Wales.
An area that, I'm just waiting for that one. And, waiting is in, if this hits the Earth, it would devastate an area the size of Wales.
Perhaps we all ought to go out and buy hard hats like we had to do when Skylab came down.
That's right. Well, anyway, Jonathan, thank you so much. I just want to answer a question that Alan Kennedy posted a little while ago, and I was looking, I couldn't find it, but I found it again now. About Mars rovers in generally, and Alan's question is, why don't they fit Mars probes with small compressors and air jets to clean the solar cells? Anybody want to take that one on?
That was because they realized that those dust devils, not daredevils, like I said this morning, were actually very effective in cleaning, opportunity and spirit for over a decade. So they realized that Mars was doing it for them. So hey ho. Now with regards to Zhurong rover, I'm not quite sure. Maybe it's not the time for dust devils at the moment. But yeah, it could be a good idea.
Also, of course, Alan, the point is that anything extra you build into a spacecraft is extra mass, of course, and that means extra fuel to get it there. So, they really have to pare everything back to the bone in order to use the minimum amount of fuel to get to its destination. It's a lovely idea, and it does make you wonder sometimes. But as Bernard said, they've been fortunate on Mars, especially with Spirit and Opportunity, that kept being blown free of dust by passing dust devils.
Yeah.
And
the InSight lander.
Yes.
They managed to find a trick to remove some of the dust, and it was related with the scoop, if I recall well. But
it was actually more dust.
I can't remember exactly.
They found that if they actually scooped up a handful or a scoopful of dust and dropped it to the ground near the solar panel, the slight air turbulence would be enough to blow the dust off the solar panel. So it was fighting dust with more dust, which was ingenious, but it didn't work long term because, as we know, InSight died because of the accumulation of dust on on everything.
And also, Mars's atmosphere is very thin.
It's very thin.
I'm not quite sure that a compressor or the edges would have to be quite powerful to be able to.
Which is all extra electricity, which means more powerful solar panels, which probably means more weight. And
Can I piggyback on that? Chris mentioned in the chat, he said, with regards, Andy, to your first comment, viewers, do you have any ideas about, future shows. And Chris said, why don't we have a session where it's just a Q&A session where our viewers can go, our viewers ask us questions and we can answer them or try to answer them live. And I think that would be a great idea for a session. So thank you very much, Chris.
Yeah, thank you for your suggestions. I've got a few here. One from Simon. How about a slot on astronomy holiday locations in the UK and Europe and beyond, a run up to the next great American eclipse? That's a good idea. We could certainly look at that, where you can actually go to do astronomy. And in the run up to the great Spanish eclipse as well in 2026. Let's not forget that, which I'm particularly looking forward to, of course. And we had some other suggestions there. And I wondered who our user Vortex was. It's Anne in Ireland. Grandkids have been at her phone again, so her name is now Vortex on her phone. Thank you for clarifying that up. Also from Simon. How about a slot on bunkum space and astronomy reporting in the media? We had a classic astrologer labelling on the BBC for Dr. Jenny. Really, oh dear, shocking, absolutely shocking. We can, if we see anything in the news week on week that is worth talking about in that vein, Simon, I'm sure we will. Do it. So anyway, I think that was it. If you do have any suggestions as to what you would like to see in the program, what you would like to see more of, what you'd like to see less of, drop us a line anytime at spaceodditieslive@gmail.com. Always lovely to hear from you. And I think with that, we will wrap things up for this evening. Thank you all for being here. Thank you again to our sponsors, Royal Valley Optics. Thank you so much to those of you who bought us a coffee this evening. That will keep us going through the night. And you're very kind, and we do appreciate it, so that we can keep things going and bringing the universe to you, which is our mission. I'd like to say goodbye to Lou, even though I've just put you back on briefly for a moment, Lou. Thank you for being here.
You're welcome.
So, yes, I've still got a problem there with his sound, but I'm sure we'll get it sorted for next week, Lou. So, and we will carry on our conversation about the solar system next week, definitely. Okay, thank you to Jonathan for your NEOWatch. We'll look forward to hearing more next week, because you can guarantee this is something that will change every week and it will never ever get boring or uninteresting. So, hang on, one person I have forgotten, of course, because he's out of kilter, is Roger. And so before we go, let's go over to Roger. I do apologise, Roger. This is what comes of putting you on towards the end. So let's go over to Roger. How are things in your night sky, Roger?
Oh, wonderful.
Yeah, I can imagine. Yeah, it's always lovely in Sparkford, isn't it?
Absolutely. So I'll just quickly go through this while I'm allowed on. So at the moment we've got the moon getting up to its waxing gibbous on the next week. This was an image that I took last night, just in case it was cloudy tonight, but it was clear again tonight. So this was it rising this afternoon.
Beautiful.
And if you were to look at it tonight, it would look roughly like that.
Magic.
And I even managed to do a galaxy as well.
God,
that's beautiful. Wow.
That is lovely. M101, classic target.
Yep, absolutely.
Beautiful.
And on my birthday last week, we had Aurora on the go.
Yeah, fantastic.
This is a bit like a Mary McIntyre image with some star trails, and you can see a hint of the Aurora glow.
Yes,
but that's what it looked like from the garden.
Quite rare at your latitudes, I would think.
Very. Yeah. Unfortunately, the previous attempt it was clouded out from myself, so I was pleased to be able to get that. And this is my very first actual viewing of an aurora.
Fantastic. Well done. And on your birthday as well. What a lovely birthday present.
I know.
Yeah.
It was cloudy here.
But earlier this evening, we had Jupiter and Mercury almost going down together at the same time on the horizon.
Yes.
So we've still got Venus shining up in the night sky, and the moon gradually working its way backwards to the summer constellations as Orion gradually sinks towards the western horizon, saying cheerio for now. But we still got Mars up in the night sky as well, so
Yes.
it's going to be a bit small nowadays, but it's still there.
Yeah, absolutely.
Not to be forgotten.
Who could forget Mars?
Absolutely. And just to conclude, we have got a little bit of an image from the James Webb.
From TRAPPIST-1b.
Yes. Just to get an idea of its orbit and size and other information on its time around from the stars.
Yes, and as Lou says, they're pretty sure because of the temperature of the planet, it's unlikely to have an atmosphere, which is a bit disappointing. But
yes, well,
I would presume that information from JWST on the TRAPPIST system is going to slowly start to trickle in.
Yes,
as we get more and more information.
Yes, because they have actually done a lot of hours of observing with it.
Yes.
So we will get the data, but of course a lot of it is proprietary data that we're not going to get till late this year. So we will see.
Anyway, so there we go.
That's it, is it? Okay, thank you so much.
Better late than never.
I'm sorry I forgot you. I
blame Rachel.
Yeah, yes, I blame Rachel as well.
Poor thing, she's not even here to defend herself.
Well, she's still here, if not physically. So anyway, Rachel, we hope you feel better soon. Hope you're relaxing and you've had a nice meal. And that definitely is it. I haven't forgotten anybody else, have I? No. Okay. No. Right. Well, God, we've done nearly a 2-hour program tonight. Yeah. There was a lot to cover, and it's just going to get like that, I think.
We're still going to be talking about Veritas and the Rosalind rover, and we also have Kareem's recorded video on the Canadian logo and all that. But we'll do all that next week.
Bernard, you're quite welcome to do it now if you wish to.
No, it's fine. I think it's getting late.
Because I think we've done about 2 hours, so I think it's probably best to hold that back. Yeah. So you've got that to look forward to. News of the European Mars Rover.
Harking back to Astro Radio tonight, isn't it?
Yeah, absolutely. It certainly is. Yeah, and yes, and Veritas as well. And there we are. So thank you all so much for watching. We do appreciate it. Thank you for being with us. Thank you for those who brought us a coffee. Much appreciated. We will be back same time next week, 8 o'clock UK time, 3 p.m. Eastern time, for another edition of Space Oddities. We will find even more wondrous things about the universe to talk about. Can you bear the excitement? So there we are. So thanks for us all. Say goodbye, guys.
Goodbye, guys.
Goodbye, guys.
Bye, guys.
And thank you to all of you for your comments and questions. And as I said, keep your favorite space images coming in. spaceodditieslive@gmail.com. Tell us how you would like to make any changes to the program, any suggestions, anything at all. Much appreciated. spaceodditieslive@gmail.com is the address to send it to. So from us all tonight at Space Oddities, we'll see you again next week. And thank you for being here. Bye-bye. Bye.
Good night.